Okay, so I'm going to talk about a special type of trapezoid. This is actually going to be an isosceles trapezoid. As you can see right here, an isosceles trapezoid is a quadrilateral with exactly one pair of parallel sides. That's what makes it the trapezoid. But the legs are congruent. So when we draw this, we still have our trapezoid, just like so. These are going to be parallel. That makes it the trapezoid part. But my legs are actually congruent here, so they're the same length. So with this, we have some special properties that go along with it. All right, so you can see that there's quite a bit of list of properties here for the isosceles trapezoid. Of course, our bases are parallel. The same side interior angles are supplementary. That's still just regular parts of trapezoids. Nothing special there. But now here's where the special parts come in. That my legs are congruent. My lower base angles are congruent. My upper base angles are congruent. My diagonals, in fact, now are congruent. And also, I have a thing called a mid-segment. So let's just kind of draw this out and kind of diagram what everything's going on here. So here I have a trapezoid. I have an isosceles trapezoid. So this part and this part, these are my bases. And they are parallel. That's what makes it the trapezoid. These legs are congruent because it's an isosceles trapezoid. Well, what that really tells us also is that because these legs are congruent, we can look at the opposite angles, and these angles have to be the same. Because if we imagine we just have a triangle finishing up like an isosceles triangle, we're going to have what's called our base angle theorem. And of course, then these angles are also going to have to be the same. Well, that's easy enough. That basically covers everything except for my diagonals here. Let me use a different color. So in this case, my diagonals going this direction, my diagonals are actually congruent. So they are the same length. So these two pink dashed lines, they're going to be the same length because my diagonals are the same length. And of course, then we have a thing called a mid-segment going right through the middle here. And our mid-segment, so this is our mid-segment. Totally can't spell, that's a D. Use your imagination. My mid-segment right here, it's really just the average of the two bases to find the length. So if I know this length here, and I know this length here, I can actually find the length of my mid-segment with a basic formula, which is going to be 1/2. I'm going to call this B sub 1 and this B sub 2. Base 1, base 2, base sub 1, base sub 2. B sub 1 plus B sub 2. Nothing more than a formula. Of course,